Good afternoon, sir.
Yeah, good afternoon. Good afternoon. Within 2 minutes, you are going to start the class.
Good afternoon, sir.
Yeah, good afternoon. Good afternoon, everyone. So as we have discussed, whenever a light of suitable energy falls on the photoresistor, the resistance of the photoresistor decreases. As a result, free electrons will move from one place to another place, and hence the current flow increases. So this photoresistor is used in solar lamps everywhere, and it is especially used in automatic street lights. Nowadays, if you see the street lights, after 6 p.m. automatically they are on. So during night time, the photoresistor makes the street lights to be turned on, and during early morning, automatically the street lights will be off. Okay. So I hope you are perfect with the explanation. Now we move to the next topic. Anyone, any question is there, you can ask regarding this photoresistor or light dependent resistor. What is the explanation, anyone? Whenever sunlight falls on the photoresistor,
The sunlight falls on the light dependent resistors in the conductor, gains the kinetic energy, and then the resistors of the resistor decreases the current, decreases the flow of resistance, and then the flow of current increases, so
Very
that
good.
the load is going to on.
Very good, very good. Load or bulb is going to on. Your roll number once again?
Name Sir Deepna,
Okay,
051.
051. Very good, very good. Yesterday also you have mentioned. So I appreciate you. So right. So this is what the explanation. So I can turn on the fan, I can turn on the bulb with the help of the photoresistors, and very soon in the lab also we will purchase the photoresistors and we place. So 5 rupees if we are able to purchase, and see if anybody is going to electric shop, you ask them to bring one photoresistor. So it is for the 5 rupees you are going to get. This is the symbol. Okay, this is the graph. They are used in automatic street lights. So number of applications. Let us say you are developing one robot eyes. It is there. No, to that robot eyes we can place small bulbs, and inside that bulb we can place the photoresistor. So whenever sunlight falls also, the robot eyes are going to open and close with the light. So we'll see different applications. Now next topic we are taking. Now here also only I'm giving one hint. Okay. Our next topic is thermistor. See, thermistor means thermal energy, heat energy. So thermistor is a thermoresistor which converts heat energy into electric energy. It converts heat energy into electric energy. So what I will do, this is the symbol. You have to remember this small change in the symbol. Explanation also will be remaining same. Okay. So only the symbol you have to write after the explanation. So I'll do one thing. I will show the animation once again. I am expecting the explanation from any one student. Let us do that one. So where is this one? Yeah, the new slide. Now, all of you observe. So directly, as I mentioned, if you are just taking the here the first animation, you can see the thermistor is similar to the resistor. It is placed in one circuit. Let us say all these circuits you will study in second year. For your application I brought. So whenever a candle is on and that candle is brought very close to the thermistor, what will it will do? Thermistor, it converts thermal energy or heat energy into electric energy. So this thermistor will sense this heat energy, and then it converts that heat energy into electric current. When current flows through the circuit, now this is called the small bulb, LED, the latest bulbs. We'll discuss the LED in brief. You can see here the arrow marks are saying that the bulb is on. So what is the working principle now? Whenever heat energy is applied on the thermistor, the resistance of the thermistor decreases. When resistance decreases, the current flow increases. As a result, any bulb connected to the thermistor, the bulb will be turned on. So in this way, thermistor is also called as a temperature sensor. Temperature sensor. Now we will see the this one, last animation, air dryer. So wherever heat energy, certain heat energy is created, that heat energy is applied on the thermistor. When heat energy is applied on the thermistor, the resistance of the thermistor decreases. As a result, when resistance decreases, the current flow increases, because we know the formula I is equal to V by R. I is always inversely proportional to resistance. So this is the explanation of the thermistor. For you, it is a short answer. Now for your understanding, I brought the second animation. Okay, so it is not okay. You can see here second animation also. Here also we are having the bulb. Okay, and preset resistor is nothing but thermistor, or the thermistor or thermoresistor. You see, when temperature is falling, resistance is increasing. Now what you have to understand, when the bulb is on here, the bulb is on when the temperature is increasing. You can see when the temperature is high, resistance is less. So where this thermistor is used, any guesses, anyone? In all the thermometers. Thermistor is used in all the thermometers. Latest we are having digital thermometer. So what digital thermometer? So the thermometer which is used for our when we get the fever, it what it will do, the heat energy is converted and the mercury level changes. But now the latest digital thermometer, they show you the reading, what is the temperature on the screen. So whenever thermistor converts the heat energy, one second, whenever yes, thermistor converts the heat energy into electric energy. Electric energy means whenever current flows through a wire, we confirm that electric energy is generated. So heat energy, whenever heat energy, yes, when a suitable intensity of heat, when a suitable intensity of heat is applied on the thermistor or brought close to the thermistor. So once again, I am repeating, whenever a suitable intensity or energy, whenever a suitable intensity of heat is applied on the thermistor, the resistance of the thermistor decreases. As a result, current flow increases, and this current turns on the bulb or the load which is connected. Similarly, hair dryer. So here we have taken the example. Whenever the heat energy is applied on the thermistor, the resistance of the thermistor decreases and hence current flow increases. As a result, the load or bulb connected to it starts to turn on. Okay. Right. So what, yes, it is also used in microwave, all of you. Microwave also, we say in the microwave light will be on. When you turn on the microwave, inside the microwave you are having small bulb. That bulb will be on. So how it is on? Whenever any object is heated, this thermistor converts that heat energy into electric energy. How it converts? Whenever heat energy is applied on the thermistor, thermistor converts that heat energy into electric energy as the resistance of the thermistor decreases. So now you see, all of you, what do you mean by the word NTC? Negative temperature coefficient. Negative temperature coefficient means whenever temperature increases, the resistance decreases. What is NTC? Whenever temperature increases, the resistance decreases. Remember this point. Okay. So this graph we are supposed to draw. So initially resistance is maximum, but as I increase the temperature, resistance starts to decrease. And this is the symbol. So both are similar. One works with the light and another one works with the heat. Now this derivation, now next topic we are coming, all of you. It will come in the mid-examination also, this essay question. So remember, all of you, it is tough. Concentrate carefully. Better you write along with me also this explanation. You remember temperature coefficient of resistance, the topic. derive the expression or explain the temperature coefficient of resistance. For you, no need to draw this image in the examination. For your understanding, I brought this image. Temperature coefficient of resistance means with the change in temperature, how the resistance of a wire changes, whether it increases or decreases, we are supposed to write with the help of mathematical formula. So whatever we explain theoretically, for all the theoretical explanation, we should write the mathematical proof. So the next topic is temperature coefficient of resistance. What it is actually? Measure of change in electrical resistance of any object or substance for changes in temperature. So whenever temperature changes, how the resistance of the conductor starts to change. So conductor, where you see in your house you are having the wires. If you open that wire, inside that one you are having the conductor. So which is made up of copper. So this one is what we are discussing. So when temperature increases, how the resistance of this copper also changes, we see. So first, how to explain? Now we are starting the derivation. Let us consider a copper or conductor. Let us consider a conductor which is working at zero temperature. That means no temperature or no heat energy is applied. So we have written here. Let us take a conductor. Every conductor has a resistance, having a resistance of R0. All of you, the letters are visible, no? Anyone student confirm?
Yes, sir.
Yes, this derivation is very important. It comes directly. Temperature coefficient of resistance. It is a new topic. Listen carefully. So how to explain? Let us take a conductor, okay, copper wire, and first assume that it is having resistance of R0, R0. You can also write R1, R2, doesn't matter. At 0 degrees centigrade or 0 degrees Celsius. That means at 0 degrees temperature, okay, the temperature is 0 and resistance is also 0. And now after certain period of time, when that conductor is placed in the presence of sunlight or when the current flows through the conductor, what happens when current flows through the conductor? First, heat energy will be created. After certain time, magnetic energy is created. We are not explaining magnetic energy now. So we are saying that when current flows through the conductor, conductor heats up, and now the resistance of the conductor be RT at 1 degree Celsius. That means at T degree Celsius. That means let R0 be the resistance of the conductor at 0 temperature and RT be the resistance of the conductor when temperature has increased with certain value. I hope all of you understood. Let us consider a conductor whose resistance is R0 at 0 temperature and whose resistance is RT at new temperature. Okay. So what we can write from the equation of temperature? New temperature value by initial temperature value. So what is the resistance of the conductor at new temperature? RT by R0. Resistance at 0 temperature. So now we say here resistance at new temperature, temperature value is T, and temperature value at zero temperature is 0. Okay, so we can write T by T0. But why we are getting T0? Let us say there is a change in the value of the temperature. So the new temperature is taken as T0 plus T. So why I am writing T0? T0 is the change in the value of the temperature. So always temperature will not be 0 and temperature will not be a constant value. It changes. So what we can write? So resistance of the conductor at new temperature by resistance of the conductor at 0 temperature is equal to temperature at new value and temperature at 0 value plus T0. T0 is a change in the resistance. I hope all students, is it clear, all of you? This first derivation point, RT by R0 equal to T0 plus T by T0 plus 0. Okay, is it okay, all of you? So with assumption, we are supposed to write derivations are taken with assumption and you are supposed to write. Okay, now from this expression, now I want RT. So R0 you cross multiply. So what happens? R0 cross multiply R0 into this expression. Okay, here it is written directly. You can write directly. Okay, you can send this one. Cross multiply RT will be here and R0 has brought to the right hand side, and then we are having this expression. Now you see all of you. What's going to happen? Here it is nothing but R0 into. So T0. This is here I have written note point. So here there is one printing mistake here. Not 0, it is T0. So what it should be, all of you, this denominator, anyone tell me? It is not 0, it is the printing mistake. So I have written here modified. What in the place of 0, what it has to be? T naught. Okay. So T naught represents the change in temperature. So RT by R naught is equal to T naught plus T by T naught plus T naught only. So what's going to happen here? Divide both the things. Here it will be 1 plus T by T naught. Understood all of you? 1 plus T by T naught. So now R naught into 1 is R naught plus I am sending R naught inside this particular expression. R naught into T by T naught. So I explain once again this one. This denominator should be T naught. Okay. So what is the expression? Resistance value at new temperature by resistance value at 0 temperature. But 0 temperature value will not be constant. Therefore, T naught we have taken, which is nothing but the new value of the change in the value of the temperature. So what is the expression? T naught plus T by T naught plus T naught. T naught plus T naught. So R naught you are sending to the right hand side. If I take the LCM, T naught by T naught, how much you will get here? If you divide, this one get cancelled. R naught into T naught plus T by T naught plus T. So you just divide this one. All the students. Okay, I'll do one thing. I just modify this expression. Yes. Just a minute. A small change is there in the derivation. We'll do. T naught plus T0, which is equal to the R naught into. Okay, we'll bring this derivation with small modification later on. Okay, we just move to this one. So this expression you are supposed to prove actually. What is the resistance value? Resistance value at new temperature equal to RT is equal to R naught into alpha into T plus 1. This will do practically. I will modify this printing mistake changes also. Right. So we just move to the next one. After light dependent resistor and thermistor, we move to the next important thing. So this word is very useful for all the electronic engineers. So what is this name? Varistor. Okay. Varistor or varistor, voltage dependent resistor. So what is the explanation? So let us say you are having a smartphone. Where it is used? Varistor. Varistor is placed inside all electronic devices. It is placed inside all electronic devices. What it will do? What it will do? It protects the electronic circuits and electronic devices from high voltages. Let us say you are having the television. Suddenly we are getting the high voltage. So what we are supposed to do? We are supposed to provide constant voltage or safe voltage to the television and to our smartphone also. Inside the smartphone, I am placing the varistor. It is not variable resistor. Remember all of you. Variable resistor is potentiometer. Varistor is new type of resistor which is placed in all electronic components and which provides a constant voltage or safe voltage. Imagine that you are charging your phone. When you are charging your phone, if your switchboard is not working properly, if the switchboard is not nice, then if you are getting the high voltage, what's going to happen to the smartphone? Smartphone also gets damaged. But even if the switch voltage is very much high, inside the smartphone, we are placing the varistor. Okay. What this varistor will do? Varistor provides a constant voltage. Now here I'll show you. So now you can see this is our switchboard AC mains, and we are having the fuse in our house. Okay, we'll discuss the fuse later on in the third unit. Now this is the symbol of varistor, and this is your circuit to be protected, means your television or your smartphone. So in our smartphone we are having the varistor. So I cannot draw the varistor inside the smartphone. So for our explanation we put it here. So varistor is placed between the supply and the smartphone. So whenever the supply voltage is very much high, this varistor will control that voltage and passes the safe voltage to the circuit. In this way, we protect these circuits. Okay, varistor is used in electronic devices to protect the circuits from high voltages. So here we have written one word. What is this simple word here? Varistor protects electronic devices from high voltages. That is a point we are supposed to write. So how it works? How it works? Okay, how it works we discuss here. So whenever high voltage, all right, here we explain this one, the varistor. voltage dependent resistor. Voltage means that from our switchboard we get the voltage. Varistor, how it will work? How it will provide the constant voltage? Varistor changes its resistance value automatically. So we are not changing the resistor value just like potentiometer. Varistor changes its resistance value automatically with the change in voltage. That means whenever high voltages are applied or whenever high voltages occurs in any circuit, in any device, automatically varistor resistance starts to change. It decreases. Varistor change resistance value gets decreased. Okay, changes with the voltage across it, making this voltage dependent, non-linear. Non-linear means it is not responding proportional to the voltage. Now you can see here the graph. So resistance of the varistor changes in an opposite direction to the voltage. Both are inversely proportional. Initially the resistance is maximum, okay, when the voltage is less. The resistance becomes maximum when the voltage value is nothing but here decreasing. So I just repeat this one. Whenever, what is a varistor? Varistor provides a constant voltage to the electronic devices or electronic elements. Whenever high voltages are applied, varistor converts that high voltage to constant voltage, and that constant voltage is applied to the circuit. So during high voltage condition, the resistance of the varistor changes and it provides the constant voltage. So in simple one line I am explaining, that is circuit is important. You have to draw this circuit. So once again I repeat this one. Varistor is voltage dependent resistor. So whenever high voltages are present in any circuit, varistor changes its resistor value automatically and provides constant voltage to the electronic circuit or electronic device. Okay, here the information is present and it is mentioned. Now we'll see the this one. So it is applications we have not written. Remember all of you, where the varistor is used. Varistor is used in all electronic devices. Only one point you can write. Varistor is used in all electronic devices. Now come to the last new type of this resistor, trim pot or trimmer. Okay, the trimmer is the resistor, trimmer resistor. So we say trim pot or trim potentiometer. So where it is used, again it is used in electronic circuits, electronic devices. So what is the use here? Okay, now all of you, where this it is used for tuning applications. In all the remote controls, in all the remote control circuits, we are having the trimmer, which is nothing but the, again it is a variable potentiometer or variable resistor. Now you see there is no new explanation here. I'll show you this one. Okay, imagine you are changing your remote, you are using the remote control and changing the channel. So when you are changing the channel, there also what's going to happen? High energy should not be transmitted from remote control to the television. So in order to overcome that process, we go for the tuning circuit. So trimmer or trim pot is used in the remote control circuits for the tuning applications. So it provides a constant tuning. So tuning and calibration. Calibration means just comparing the values here. Okay, when they are used as a variable resistance. Okay, so it is used as a variable resistor. They are called the preset resistors or normally mounted on PCB. PCB means what? All of you, printed circuit board. If you open and see your smartphone or television, you will see the entire circuit. That's entire circuit which is green color or silicon chip is nothing but the printed circuit board. Adjusted by a screwdriver. It is a variable knob. You can see your variable knob. Resistor. So what is trimmer? Trimmer is a variable resistor which is used only for the tuning applications. Remember this point. It's used only for the tuning application. Examination also the same point you can write. A trimmer is a variable resistor which is used for the tuning application in the remote control. This is the symbol of the trimmer. Okay. Yes. Actually, this is the definition. Trimmer potentiometers. They are called as potentiometers, and preset resistors, which are variable resistors, or small variable resistor, which are used in circuits for tuning and calibration, comparing the values. So just draw this symbol. No need to for any explanation. So now for your
Sir,
understanding, yeah, please.
it
Tell
is
me.
also used in the weight machines also, no, sir?
Weight machine is correct. It is also used in the weight machine, but very large size. Weighing machines also it is used. That's good. Trimmer, right? So now the image what I am showing here, it is only for your understanding. See, all of you, yesterday we have seen the colors, resistor outside, but inside that one what we are having, yesterday we have studied metal film. So inside this colors what we are having, practically we are having the different type of metals and insulating material. No need to study for exam. For your understanding, I am showing the image. So here also, first one diagram we have shown what are the different types of resistors. Now you can, in order to have the practical explanation, resistor symbols we have given. Okay, just you see this one. If you go to any electric shop, if you see the resistor, you must be in a position to tell the name of that resistor, which resistor we are using in that manner. So for that reason, we are sharing this one. Okay, that derivation, what it is there in the syllabus, that is temperature coefficient, we will modify that one and we'll take in the next class. Tomorrow we'll complete the second unit, we'll do the revision, and I make you people to perfect for the external examination. I'll give you the questions also. Those questions you can study, okay, for the exam. Any question is there? Please ask me now. Anyone?
No, no, sir.
Okay, no question.
No, sir.
So trimmer, whatever it is there, you can study. That derivation we'll see tomorrow in the next class. Okay, I'm just ending this one.
Thank you, sir.
Thank you.